factors, like for example, x of the a times x to the a, you add them.
Yeah. So yeah, when you multiply two different things together, you add the exponents. When you raise something with an exponent to another exponent, that's when you multiply the exponents together. But that would be about the best you could get that looking. I'm just going to clean up this line a little bit. No. So if you get something more difficult like this, I used to have students simplify stuff like that, but I realized it was just real tedious. Although it wouldn't be that bad, to be honest. But for a more challenging problem, I'll probably give you a pass on simplifying or reducing. But that will be spelled out directly on the exam. It'll say, like, do not reduce this one. But if it doesn't say, you know, you can do whatever you want. But yeah, for something like this, I would just leave it as is. All right, a little bit of a more challenging one there. Anything up there not clicking, not making sense? Pretty good? Okay. Moving right along today. All right, so this is something, this would be about the upper limit of what I would expect you to be able to reduce when we get through this one. I don't think it's too bad. It just requires a little bit of multiplying. But again, you know, you're going from kind of college algebra land where maybe, you know, you reduced a polynomial or factored a cubic or a quartic, and now you're looking at like half a page of work just to do one problem. So it is intimidating. Yeah. Yes, that is correct. Now that also kind of depends on, like, if you need a calculator for like multiplication or for simple exponents, then you might want to use one, but I don't require the usage of a calculator. Like, I don't build my tests where you have to use a calculator on any problem, so it should be good. But yeah, you are welcome to use calculators. Just which one? I haven't done anything with it. I'm confused. No, this one could be simplified. This one isn't bad. Yeah. All right. Top function, f of x. Bottom function, g of x. So we've got f of x equal to x squared minus 5x. So our f prime of x would be equal to 2x minus 5. So nothing too terrible yet. G of x, our denominator. We've got 3x cubed minus 4x plus 1. And then g prime of x would be 9x squared minus 4. So we will have a little bit of work to do on this one, but I don't think it's prohibitive. I think we should be able to get a nice solid answer out of this. All right, so, and let me write out kind of what we're doing exactly here. So we're taking the derivative of x squared minus 5x over 3x cubed minus 4x plus 1. So we have f prime, so 2x minus 5 times g, which is 3x cubed minus 4x plus 1. So f prime g minus g prime 9x squared minus 4 f. So same exact quotient rule. And really past this step, all of your calculus is pretty much good. There we go. And then in our denominator, I've never actually seen a case where expanding the denominator is worth anything. So in your denominator for that square, it's rare that you're going to get anything to cancel out from that denominator term. So you can just leave it as the square. It's pretty common. But, we can definitely work out the numerator a little bit. That's not bad. We're going to give ourselves enough space here. All right, so the first part, the 2x minus 5 times 3x cubed minus 4x plus 1. So that would be 6x to the 4th minus 8x squared plus 2x minus 15x cubed plus 20x minus 5. So that's our first part. And then I'm just going to leave the minus sign on the outside, and we're going to figure out what that product is first. And be really, really cautious with that. So watch out for stuff like this. Usually a pretty frequent cause of missed points. Because what students will do is they'll be so worried about multiplying that out correctly that they'll only apply that negative sign to that first piece. So to the first, like 9x squared times x squared. But remember, it's going to get applied to each individual term, and we've got to FOIL that out. So it might be in your best interest just to leave that negative sign out, FOIL, and then deal with it instead of trying to do all at once. But all right, let's see here. So 9x squared times x squared is 9x to the 4th, and then minus 45x squared. Minus 4x squared plus 20x. 45x cubed, let's see. Yes, it would be. Just double check everything else. Yeah, that looks good. Okay, so we've got 9x to the 4th minus 45x cubed plus, minus 4x squared plus 20x. And then in our denominator, we still have the same thing down there. We haven't done anything with it. All right, so up top, not a big deal. 6x to the 4th minus 9x to the 4th is negative 3x to the 4th. And then let's see, x cubes are going to come next. So negative 15x cubed minus negative 45x cubed, so plus. So if I take negative 15x cubed and I add 45x cubed, I get positive 30x cubed. And then x squared, so I've got negative 8x squared right here, and then I've got negative 4x squared, so positive. So that turns into negative 4x squared, so I have negative 8 minus negative 4. 2x plus 20x gives me 22x on the outside, and then minus 20x leaves me with just 2 of them. And then I've got negative 5, and that is my only constant term. So there's our nice looking polynomial up there. And then down in the denominator, 3x cubed minus 4x plus 1. So that's a pretty good example of probably a more moderate test question. Josh, yeah. Oh, squared. Yeah, I left off that square. That's the other thing to look out for, which I make a lot, transcription errors. Not even math errors, but just you're looking at your work, you're looking at the problem, and you just leave stuff off. Just be real cautious for those because those can really set a problem off.
Quick question.
Yeah.
Whenever you have the negative, right? Like
Mhm.
minus 9x squared minus 4